All right, so this is our second day of solving systems of equations. And today the method is solving by addition. Yesterday we'd solved by graphing, and that works great when the equations are in y equals mx plus b form. But sometimes our system's not going to be written that way. If you notice, these equations in this system are written in standard form, which is ax plus by equals c. Now we could graph both of these using the intercept or the Raccoonize method or the solving for y method for both, but there's actually a method that's a little faster than that, and that's called addition. And all we're going to do is line up our equations so that the x's are on top of one another, the y's are on top of one another, and the numbers are on top of one another. And then just like it says, all we're going to do is add the two equations together. So negative 2x plus x, those are like terms, I can add them together. Remember there's a 1 in front of that if there's not a number written. So it's negative 2x plus 1x, which would be negative x. Positive y and negative y, when I add them together, they cancel out. So I get 0. So I'm not going to write anything for that since it's basically 0. Then I'm going to take 4 plus negative 2, which is 2. So by adding them together, I have canceled out one of the variables. So now I can just solve this for x. And the way you solve this for x, since it's negative x equals 2, I divide both sides by negative 1. Those cancel, I get x equals negative 2. So I now have half of my solution. Because remember, we're looking for the point where they cross. So I'm looking for an xy. I just found the x. Now what I can do is take that x and plug it into either equation above and solve that equation for y. And you can pick either equation, it doesn't matter. So I'm going to plug it into the top equation, which means this x is going to become negative 2. So I would read negative 2 times negative 2, which would be 4, because a negative times a negative is positive. And then I'm going to write the rest of the equation. Now to solve this for y, I simply subtract 4 from both sides. It cancels over here, I get y equals 0. And that is the other half of my solution. So again, we're going to write the solutions as a point. And just to prove it doesn't matter which equation I plug in negative 2, I could plug it into the bottom equation, where I'd make this x a negative 2. I'd write the rest of the equation over, so the minus y and the minus 2, and then I would solve this for y. So I add 2 to both sides, those cancel out, I divide both sides by negative 1, and 0 divided by anything is just 0. So either equation gave me the same answer. Let's try a second example. Again, this is called addition. All you're going to do is add them together. So 2x and negative 2x is 0. They cancel each other out. And then 2y plus 5y is 7y. And 14 plus 21 is 35. Now I have an equation with just y in it. So I divide both sides by 7 to solve for y. And I get y is 5. So I am halfway home again. I know that the y of the point where they cross is a 5, so I can write that here. Now I just need to find x. So I take this y and plug it into one of these two equations. Now, when you're choosing which equation to plug into, I like to choose the one that looks the easiest. The top equation is all positive, and the bottom equation has this negative 2. So I'm thinking I'm going to avoid that negative 2 and plug this y into the top equation. Now, one way to plug this in is to rewrite the equation, but instead of writing y, I put that 5 in parentheses, because that y is really going to be 5. And I have to multiply. So it'd be 2x plus 2 times 5 is 10, equals 14. Now I'm going to solve for x. This is from last unit. That cancels. I get 2x is 4. Divide both sides by 2. I get x is 2. So that's the second part of my solution. We're always going to write our solution as a point, so it should look like this, 2, 5. Here's a third example. Again, this is addition, so all I do is add them together. 2x plus negative x is just x. Positive 4y and negative 4y, they both cancel out, so that would be 0. I'm not going to write it. And then I bring the equal sign, and 46 plus negative 41 is 5. Now, this one's already solved, because it already says x equals 5. So that means I have half my answer already. And now I'm going to plug this 5 in for one of the x's in those two equations. Again, pick the equation that looks the easiest to solve. The bottom equation has 3 negative signs. That's just 3 chances to make a mistake, in my opinion. So I would plug the x equals 5 into the top equation, which has all positive numbers. Again, it doesn't matter which one you pick. I'm just trying to pick the one that makes my job the easiest. So I'm going to plug that 5 in for x. So I'm going to rewrite the equation. 2, put 5 in parentheses, that's my x. And then I have plus 4y equals 46. Now, 2 times 5 is 10. Now I'm going to solve this for y. So you get rid of the 10 first by subtraction. Remember, you always do the opposite. It was positive 10 here. I'm going to subtract 10 from both sides. I have 4y equals 36. Then I'm going to divide both sides by 4, and I get y equals 9. So that's the second half of my solution. And here's my last example. Again, we're just adding. So these two cancel each other out. 4y plus negative 3y is just y. And negative 29 plus 28 is negative 1. So again, this one is already solved for me for y. Now if there had been a number in front of y, I'd have to divide both sides. But since y is by itself already, I already have the answer. So that's half of it. Now I'm going to plug this into one of those two equations. Your choice again. I'm going to do the bottom one this time. Even though it has a negative 3 here, when I plug in negative 1 for y, it's going to be negative 3 times negative 1, which is going to be positive 3. So because this 3 was negative, and the y I'm plugging in is negative 1, a negative times a negative is positive. Now I just solve for x, so I subtract 3 from both sides, I get 25, divide both sides by 5, I get x equals 5. So that is the second half of my solution. So solving systems by addition is really quite simple. All you need to do is actually add the two equations together, and you will get one of the variables. If you notice, every time we did an example here, one of the variables simply cancel each other out, like the plus y minus y, 2x negative 2x, 4y negative 4y, and negative 5x, 5x. Okay? So something will cancel out, then that will give you one of the variables, and then you take that one, plug it back into one of the equations, and solve for the other. And pick an equation that looks the easiest to deal with.